Hey, I'm Azar. For this audio essay in Digitalization in a Sustainable Society, I want to talk about something that really grabbed my attention recently, which is bias in algorithms and AI. I've been reading a book called Invisible Woman by Carolina Cradio Perez, and that's actually what inspired me to choose this topic. The book covers a lot of different areas where gender bias shows up in data. But for this essay, I decided to focus specifically on how biased data affects AI systems and algorithms. What really struck me is that these systems are often described as neutral or objective, but they are built on data that reflects existing social structures. That made me think a lot about this course because we've been discussing how digital technologies do not exist in isolation. They are shaped by society, by history, and by power relations. And they can also reinforce them. In this recording, I'm going to play short clips from expert talks, reflect on what they are saying, and connect that to well-known research on algorithmic bias. So it's a mix of expert voices, my reflections, and research, all focused on what it means for building more responsible and sustainable digital systems. Before getting into my own perspective, I want to start with an expert voice that clearly frames the problem. Here's the clip from Carolina Cradio Perez in an interview about her book Invisible Woman. This part really resonated with me and connects directly to the points that I want to make. Let's hear the interview.
I think data has always been incredibly important because it's about how we allocate resources partly. And if you have faulty data, you're going to allocate resources in a way that is biased towards men. But absolutely, when it comes to algorithms, the issue with that is twofold really. First of all, it seems that coders just simply aren't aware of this as an issue. And so not only is the data upon which they're training their algorithms hopelessly male biased, they aren't doing anything in the coding to correct that. And the other issue is that machine learning gets better. And so when it comes to sexist data, it means it gets more sexist. And research does show that it's what it does. It amplifies biases.
What she's talking about here is not just a concern in a theory. It's a well-known research that shows this is happening in real AI systems. One of the most influential studies on this was done by John Boalowin, who was a researcher at MIT Media Lab, together with Timnit Gebru, who at the time was also working in AI ethics research. The study is called Gender Shades. In this research, they tested commercial facial recognition systems from major tech companies, specifically IBM, Microsoft, and Face++, to see how accurately they could identify different faces. What they found was a clear pattern. The systems worked best on white male faces, and much were worse on women, especially women with darker skin tones. In some cases, the error rates for darker-skinned women were above 30%, while the error rates for white men were closer to zero. So the same system was performing very differently depending on who it was analyzing. What's really important here is that researchers didn't argue that algorithms were intentionally sexist. The main issue was the training data. These systems had been trained mostly on images of lighter-skinned men, which meant that the algorithm learned to recognize those faces best. Everyone else was underrepresented in the data. That was all. And this directly connects to what Carolina Cradio Perez is pointing out. When machine learning systems are trained on biased data, they don't correct that bias by themselves. Instead, they learn it, optimize for it, and then scale it up. From a critical perspective, this shows that algorithmic bias is not just a technical problem that can be fixed with better code. It's a socio-technical issue. Decisions about whose data gets collected, who is represented, and who is left out are deeply connected to power, inequality, and history. When these decisions become embedded in digital systems, This is start shaping real-world outcomes in the ways that are difficult to see and difficult to challenge. Building on that, there is another perspective I want to bring from a recent research by Mosavideng Joshi. Their paper titled AI and Discrimination, the Sources of Algorithmic Biases. It's published in Database for Advances in Information Systems in 2024 and looks how bias appear at different stages of AI development, not just in data itself. According to them, bias can emerge during data collection, in algorithm design, and even in how algorithm is used in real-world context. They point out that discrimination is likely to arise when data reflects structural inequalities, is missing relevant input, or includes data that is correlated with protected attributes. They also explain that biases in the process of algorithm development could include biases related to problem definition, feature selection, model selection, objective function, and evaluation metrics. And one more thing they stress is really important, that digital discrimination through algorithm use occurs when the outcomes of a model are misinterpreted by or misapplied to users, thus leading to certain individuals being treated differently. What I find really interesting here is how this complements what we saw with the gender shades. Gender shades showed how bias training data can directly lead to discriminatory outcomes. But Mosavi and colleagues remind us that bias can creep in at multiple stages, and even when a system designed with good intentions, it can still produce unfair results if these stages are not carefully managed. It really reinforces the point that algorithmic bias isn't just a technical problem, it's a deeply socio-technical, connected to existing inequalities, and it can just be solved with a better code. And while gender shade study gave us a clear evidence of biased AI systems, it's also powerful to hear from Jo Boavini herself, one of the study's authors and founder of Algorithmic Justice League. In her TED Talk, How I Am Fighting Bias in Algorithms, she reflects on the same issues I've been discussing, how facial recognition systems fail for darker-skinned faces, a phenomenon she calls coded gaze, and how these biases are not just technical but social and ethical. Here's the short excerpt where she explains why, who codes, how we code, and why we code really matters.
So what can we do about it? Well, we can start thinking about how we create more inclusive code and employ inclusive coding practices. It really starts with people. So who codes matters. Are we creating full spectrum teams with diverse individuals who can check each other's blind spots? On the technical side, how we code matters. Are we factoring in fairness as we're developing systems? And finally, why we code matters. We've used tools of computational creation to unlock immense wealth. We now have the opportunity to unlock even greater equality if we make social change a priority and not an afterthought.
What Boalonvini highlights in her TED Talk really resonates with the patterns we've seen in the research. She emphasizes that who codes matters, how we code matters, and why we code matters. These points remind us that technology is shaped by people, their decisions, and the social structures around them. Her talk makes it clear that bias in algorithms isn't just a technical problem again. It's just social, ethical, and tied to real-world consequences. Listening to her talk, I realized how easy bias can be embedded in systems without anyone intending it. It's not always a carelessness or malice. It's often about assumptions, oversight, and trust in the tools we use. Boalonvini's examples of facial recognition failing on darker-skinned faces really brought that to life. From my own experience in computer science, working as a data analyst and later building data pipelines as a data engineer, I can relate to this in a practical sense. When I was building systems, it was all about speed, efficiency, and making products work We focus on KPIs, getting results, scaling solutions, and never really thought about how data we were using could reflect social biases, or how small technical decisions could lead to unfair outcomes. Hearing Bologna's talk about these issues really made me think about my own work in a different way. Not just what we build, but how rarely we stop to question the assumptions behind it. I used to trust that if something was automated and data-driven, it was probably neutral. Looking back now, I realized that this wasn't about not caring, it was more about not stopping to question those assumptions. That's why algorithmic bias feels so important to me now. It shows how digital systems can repeat existing inequalities, even no one actually intends that to happen. If data reflects unequal structures in a society and we don't question it, those inequalities can end up built into a system. And once the system scales, the impact scales too. For me, this makes digitalization feel like it has two sides. On one hand, it can make things easier, faster, and more efficient. On the other hand, if we're not paying attention, it can also cause harm in ways that are not always visible right away. The idea that technology is neutral doesn't really hold up once you start looking closely at how these systems are designed and used. So my main takeaway isn't that technology is good or bad. It's that digital systems reflect human choices, the goals we set, the data we rely on, and the questions we don't ask that all shape their outcomes. Becoming aware of that has genuinely changed how I think about digital systems and my responsibility around them. And this is where I see the link to sustainability. A sustainable digital society isn't just about innovation or efficiency. It's about building systems that people can actually trust over time. Systems that don't quietly disadvantage some groups while benefiting others. That kind of sustainability requires awareness, reflection, and sometimes slowing down to ask better questions instead of just pushing for faster solutions. Thanks for listening, and I hope this gives you some perspective on the challenges and opportunities of building fairer, more inclusive digital systems too.